Hello everyone, my name is Mahima and in this video I will be presenting Multi-morbidity Index project. To begin, I will talk about the history and background of Multi-morbidity Index. So, multi-morbidity is defined as the co-occurrence of two or more chronic conditions and is used for assessing and predicting the prognosis of patients based on the history of their illnesses and current diseases. Here I have added a few citations and links to where you can learn more in detail about the multi-morbidity concept. So first, I will compare the Charlson scoring that we did before the midterm versus likelihood ratios, which was a part of the Multi-morbidity Index project. Charlson scoring gives a score for each patient based on a category that their diagnoses are categorized into. The higher the score, the worse the prognosis is. For likelihood ratio, though, it's calculated based on the patient's diagnosis. Likelihood ratio defines how much more likely a patient with a diagnosis is of dying compared to a patient that does not have that diagnosis. On the picture to the right, you can see that a diagnosis of 941.07 has a likelihood of 21.2 times of dying compared to someone who does not have that diagnosis. Next, we did ontological adjustments where we readjusted all the likelihood ratios to predict a better number that a patient would die from a disease. If a disease or ICD-9 code does not have enough observation to accurately predict, we use the code on the left side of the screen to take them down a single digit in order to calculate new likelihood ratios. Basically, the ontological adjustment improves the accuracy for treatment effectiveness in patients with rare comorbidities. Next, we did body system adjustments. So first we categorized the different ICD-9 codes into different categories based on the body systems, such as circulatory system, respiratory system, digestive system, and much more. Then we multiplied each body system to get the product of maximum value. Finally, the output shows all calculations and predicts a value for each ID. Then we had to do a body system progression for this presentation using one patient, which is just one ID. I decided to select ID 321690 because it had no nulls and had only 40 ICD-9 codes, which is easier to analyze rather than 300 ICD-9 codes. Using ontological adjustment code, I added the last three lines of codes. The third line where it says order by ICD-9 and age at DX ascending makes the outcome much easier to read. So the first age at death that I found for this patient ID was 74.92, which was the youngest age for this patient. At this age, the patient had 8 different diagnoses for the different body systems, which I have marked in red. The next age I found for this patient was 76.75, and you can see the progression of the patient's diseases in this picture. At this age, the patient had 18 different diagnoses for the different body systems. The third age I found for this patient was 77.08, where you can see that the patient is diagnosed with more body systems and the progression keeps going on. 32 different diagnoses for the different body systems are recorded for this age in red. The final age I found for this patient was 77.25, which was the patient's age at death. 35 different diagnoses for the different body systems are recorded in red. Different studies have shown that multimorbidity accuracy is better to predict prognosis for diseases. So here I have compared the Charlson accuracy with the multimorbidity accuracy. You can see here that the area for Charlson accuracy was 0.06 and the area for multimorbidity accuracy was 0.86. This tells us that the multimorbidity index is better at predicting the prognosis of different diseases because it has a higher accuracy. And that's it for this presentation. Thank you for watching.